As of August 7, 2025, Baykar has officially entered the serial production phase of the Bayraktar Kızılelma Unmanned Combat Aerial Vehicle, UCAV, a project regarded as one of the most technologically ambitious developments in Turkey's defense and aerospace sectors to date. This significant milestone is the result of years of indigenous design, engineering, testing, and flight trials. The Kizilelma program began as part of a larger national initiative to achieve self-sufficiency in advanced aerial combat systems, with emphasis on technologies such as stealth, autonomy, and jet-powered performance, all achieved without reliance on foreign manufacturing systems or supply chains. The Kizilelma first made headlines in December 2022 with its successful maiden flight. That flight marked not only a technical achievement but also the beginning of a rigorous test program involving multiple prototypes that evaluated flight performance, engine reliability, flight control software, radar integration, and autonomous mission capability. By 2024, several flight tests had demonstrated the drone's ability to fly at high subsonic speeds, operate with high stability under multiple weather and altitude conditions, and manage real-time decision-making processes via AI-supported avionics. The test program expanded through early 2025, at which point Baykar confirmed readiness for serial manufacturing. According to statements from Baykar leadership, including Selçuk Bayraktar, the company's chief technology officer, the 6th Kizilelma airframe is now being assembled on the production line, and subsequent units are expected to follow at a consistent rate. Baykar has scaled its production infrastructure to meet demand, with the assembly process carried out in its advanced UAV production facilities in Turkey. These facilities utilize a combination of domestic supply chains, composite manufacturing, and quality control systems designed to support scalable, reliable production of next-generation aerospace vehicles. All indications suggest the production process is proceeding on schedule, and there have been no reported delays or technical issues during the initial serial manufacturing phase. Kizilelma is fundamentally different from traditional UAVs due to its design philosophy and intended combat roles. It is built with a jet engine propulsion system, enabling it to achieve speeds close to Mach 0.9. This performance allows for rapid response missions and long-range tactical flexibility. Unlike propeller-driven drones, Kizilelma can more effectively integrate into fast-paced air combat scenarios. It has a service ceiling well above medium-altitude UAVs and is capable of operating in contested airspace where high-performance aircraft are typically required. The aircraft has a combat payload capacity of approximately 1,500 kilograms, which includes internal bays that maintain the drone's low observability profile. This allows it to carry a diverse range of sensors and munitions while remaining stealth-capable. Baykar has also integrated an AESA active electronically scanned array radar system, offering advanced targeting, tracking, and battlefield awareness functionalities. The radar system enables multi-target tracking and supports both air-to-air and air-to-ground engagement scenarios. The drone also features electro-optical targeting and infrared tracking systems, further enhancing its all-weather, day and night operational capacity. Autonomy is a key part of Kizilelma's operational design. The drone is capable of executing complex missions without real-time human control, including target identification, threat prioritization, and adaptive mission planning. Baykar has invested heavily in AI-supported flight control systems, which are trained using machine learning algorithms on flight test data and simulated combat scenarios. These systems are not only capable of stable flight and maneuvering but also dynamic adaptation during mission execution, allowing Kizilelma to function in GPS-denied, jamming-heavy, or communication-compromised environments. Another distinctive capability of Kizilelma is its ability to conduct operations from short runway or naval platforms. Baykar designed the aircraft with the intention of integration onto Turkey's multi-role amphibious assault ship, which is configured to support unmanned aviation. This sea-based operational capacity provides strategic advantages in terms of force projection, rapid mobility, and theater flexibility. Kizilelma's landing gear, wing configuration, and software systems are optimized to perform landings and takeoffs on short deck lengths, enabling it to be used in missions far from fixed land-based airfields. With the beginning of serial production, Turkey becomes the first country to enter large-scale manufacturing of a jet-powered, stealth-capable unmanned combat aircraft designed for both air dominance and strike missions. While similar systems are under development in multiple nations, none have reached confirmed serial production as of this date. This gives Baykar a strategic lead in the emerging global market for high-performance UCAVs. While there have been expressions of interest from other nations in acquiring the Kizilelma platform, No specific export agreements have been publicly disclosed, and the company's current focus remains on domestic operational readiness. Initial delivery to Turkey's armed forces is expected to begin in 2026. Before entering full operational service, the aircraft will undergo further integration testing, operational evaluation trials, and pilotless combat simulations under military supervision. The goal is to ensure the platform meets readiness criteria for deployment in a variety of tactical roles, including border defense, aerial interception, electronic attack, and strike missions. Integration into broader command and control networks is also underway, and Kizilelma is expected to become a central element of Turkey's future aerial warfare doctrine. This aircraft is also being developed in parallel with other AI-based autonomous systems designed for air combat teaming, including manned-unmanned teaming technologies and drone swarms. Kizilelma is built to be adaptable for those future roles. Its onboard architecture supports data fusion from multiple drones, real-time data links, and shared targeting among airborne assets, enabling collaborative combat operations without the need for continuous human intervention. The successful transition to serial production of Kizilelma underscores Baykar's rapid technological advancement and its strategic investment in unmanned systems. This development further establishes Turkey as a major player in the advanced UAV sector, especially in platforms designed for high-threat, high-performance environments. As of today, August 7, 2025, all evidence from official sources, production records, and independent defense monitoring confirms that Baykar has entered a stable and ongoing production cycle for Kizilelma. The project is progressing without known delays, and its upcoming deployment is expected to significantly influence both national defense capabilities and international interest in new-generation UCAV systems.